Hi everyone, today we are going to learn dynamic partitioning placement algorithms for the best fit. Okay, we are going to execute all our process using this diagram, and we are going to execute all this process inside this diagram. Okay, first of all, we need to know U is use and H is hold as it is stated here. So now the first thing we have to do here is we have to, if we let's say we can observe if there is two h after each and another, as it is here h. Actually we can make it one empty space, which is like this. So we can okay, so it will become like this. Same goes to here, we can see 2h over here, so just delete both of these, all this h, and also this thing. Same. Okay, now we can find all these empty spaces over here and also here. So what is for this h, the single h over here? Same goes to this thing also. What we can do here is just delete and also delete and remove. Okay, so we have 5 1 2 3 4 and 5 empty spaces. So okay, for the h1, the size of kilobytes in this empty space is, we have 30 here, we have 60 here, so in between the empty space over here is 30. For the h2, the size of empty space is 60. 210 minus 150 is 60. For the h3 is 80. For the h4 it is 110, and for the h5 it is 760 minus 610 is 150. Okay, now let's execute our process over here. So how to execute this process over here is P1. Okay, if the size of, for the best fit algorithm, we should scan all the empty spaces and choose the most suitable hole to fit in our process. Let's say if our process P1, process 1 is 15, we should find the nearest empty spaces over here and execute in it. We can't execute this process 1 if the size of kilobytes is lesser than the process itself. Okay, for the process 1 it is 15. So what we can do is, from here which one is the nearest to 15 is 30. So we go to the h1 empty space 1 and we execute process 1. So process 1 15, process 1 15, process 1 15, and process 1 is P1 is 15, so 30 plus 15 we will get 45 here, and once we plus 15 here, we have to minus from the empty space 1 15, which we will get 15 over here. Once we plus 15 here for the process 1, because the size of kilobytes is 15, so we have to minus 15 from the empty spaces. Okay, so same thing goes to process P2, process 2, which is 50. So the nearest process to the 50 is H2. H2 is over here. So same thing, you have to go there and fit in process 2. So process 2 over here, so same, we have to plus 50 here, so we will get 200. 50 plus 150 will get 200 here, and same thing we have to go minus 50 here, so we will get 10. So same thing we will execute for all the other empty spaces using the nearest kilobyte, which we will get the answer such as, so we will get, so p1 here, p2 here, p4 here, p3 here, and p5 here. P5, oh, sorry, I forgot to update the empty size of kilobytes, which will become 30 here. Okay, so let's see. For P6, we already execute 5 process, but we haven't execute process number 6, which is 10. So what will happen if we execute this 10 is, we can execute this 10, we have to find the nearest or the exact amount of size of kilobyte. So we see here, the empty space that has exact amount of 10 is empty space number 2, which is 10. We can't choose 15, because 15, although it can fit 10, but we have another value, I mean another size of kilobytes in an empty space, which is exactly can suit the process 6, which is 10. We can't choose 5 because it is lesser than 10. So what we can do is, we go to empty space number 2, which is here, and we execute process number 6 here. So once we execute process number 6 here, so which is, we already updated here, so we have to minus here 10, because the size of kilobyte is 10 for process number 6. So 10 minus 10 will be 0 here. Okay, so we already finished execute everything for the best fit, which is, we have to scan all the empty space, which is scan all the hole and find the suitable hole for our process. Okay, what can we do with the empty space over here after executing all the process? Very easy, just go to the diagram and just put the h, which is hole, here, here, and also here. Okay, thank you so much.